So our group chose to rearrange the bracket design by shifting around the holes and the oval shaped holes by spreading them out along the edges and in the middle. The anchor here at the top left corner slid down to more of the center, and this indentation was slid down here. We did this to spread out the holes punched in order to make manufacturing easy and to strengthen the bracket. Our main concern with this design is where the two folds touch. Right here it's one solid piece. We decided to make it two separate pieces in order to make manufacturing easy. This could weaken the bracket. We have yet to decide that. Now we'll be moving on to the manufacturing steps. Number one, we'll stamp out the blank. We'll be using a compound die for this. In this step we can cut out two patterns in one, cutting out each corner and dividing it in an angle like this. Step two, we'll be punching out the holes. We'll be using a double bevel shear for increased accuracy. It'll look much like this template wise. Each hole will be cut first, and then in another round of punching out holes, the ovals will be cut. We calculated the punching force down here, the holes being 5,920 pounds each, and the ovals at 20,890 pounds each. The annealing process comes next in order to ease bending the material without cracking it. This is best done at 660 degrees Celsius and allowing the metal to slowly cool. After the metal's been annealed, we'll then draw out the indentations using a form block, and then we'll bend the sides at 93 degrees to allow for spring back. Now I'll speak a little bit about the materials we chose and the dimensions of the bracket. We decided to go with aluminum 6061 for its strength and have a thickness of 1/8 of an inch. Using these dimensions here and in the drawing, we'll come out with an area of 304.6 inches squared and a volume of 38.1 inches cubed. Taking into account the density of aluminum, we then get the weight of the entire blank to be 3.71 pounds. After subtracting off unused materials that have been cut out, we can then calculate that we are using 95% of the material that we've cut.